Hey, good day, guys. You welcome again to my channel. And today in this tutorial, I'll be showing to you how to estimate column loadings. If one of the questions in your heart concerning structural engineering is how to estimate the loads that's been transmitted through columns within a structure, this video will help you answer a lot of the questions in your heart. And that's exactly what we'll be doing today, how to estimate column loadings. In case you're joining us for the first time, or probably you're finding your way through my channel on YouTube for the first time, I am Joshua the designer. This is where we'll make amazing tutorials on structural engineering, and you want to do well by subscribing to this channel, like using the like button, share my videos with your friends, your colleagues that should get better with structural engineering, and that way we're good to go. All right, straight into what we have for today: how to estimate column loadings. Right about now, what you can see on my screen is the floor plan of a building, and in this case we are treating as a residential building, and we can see the section also showing us that we have the ground floor, first floor, second floor, and then the roof. All right, so we want to estimate the loadings on the column. So our major adventure this today will be around column B2, column B2, which is this column, which is column, the central column, column B2, the central column. All right, so how then do we go about it? But before we begin to do one or two things around that, we may want to establish the parameters and some details that will help us out in our estimation. All right, so we want to note the following details. All floor beams are 450 by 225 mm. The roof beam 300 by 225. The columns 225 by 225. Then you want to also note that the finishes is taken as 1.2 kilonewton per meter square. Partition is taken as 1.5 kilonewton per meter square. The roof load, and we want to combine the dead load together with the live load to be 2 kilonewton per meter square. Then we'll have the wall load. The unit weight of the wall 2.87 kilonewton per meter square. Then we have the slab thickness. We want to take that as 150 mm. All right, and we want to consider this building as residential. So for the live load, the occupancy being residential, we are considering 1.5 kilonewton per meter square. All right, so this information is necessary or will be very, very vital as we go ahead in doing our calculations, estimating our loads. All right, so we want to just go ahead now and do the necessary things to achieve our enterprise. All right, the first thing we want to do is to determine our slab loadings. All right, but before we do that, we want to look into the load um, chase down. All right, you may just call it the system of how the loads are being transferred down to your foundation, starting from the roof. All right, so while following the same principle or the same system, the roof load to the roof beams, and the roof beams here in this case being transmitted to the columns. Now this system that we have here represent that for the first floor, and we have the second floor slab going to the second floor beam, then goes to the second floor column. This sorts for the second floor, or rather we have just played with our floor titles so that it won't confuse our communication. This is the roof, this is the second floor, this is the first floor, and this is the ground floor. So we want to talk about the second floor here, then we'll talk about the first floor here. Yes, I believe somebody is confused right now. The roof to the roof beams and the roof beams to the columns, that's represent for the second floor to the roof, second floor to the roof. And this one, the second floor slab, take transfers the load to the second floor beams, and from second floor beams we get to the first floor columns, first floor columns. So that's for the first floor. Then we move next to the first floor slab to the first floor beam, and then we have the ground floor column. This stands for the ground floor system of load transfer. Then finally we have our foundation. So this is primarily how the load works in transfer from the roof to the roof beams, the roof beams down to the column for the second floor, and for the second floor to the first floor we have the second floor slab, goes down to the second floor beams, then down to the columns. All right, then for the first floor it takes for the first floor slab down to the first floor beams, and from the first floor beams down to the ground floor columns, then it goes right into the foundation. All right, so this is just a basic understanding, so let's get into our calculations. All right, so we want to first calculate our slab loading, of which by now we should be familiar with one or two things around the slab loading. So the first thing we want to calculate is the slab own weight, and we've been told from the information we have earlier that the slab thickness is 150 mm. So we want to make use of that information. 0.15 multiplied by 24, that gives us 3.6 kilonewton per meter square, right? So we have the finishes also, of which we have been given that information earlier to be 1.2 kilonewton per meter square. We have the partition as well, we have been given that information also to be 1.5 kilonewton per meter square. Okay, in all we have 6.3 kilonewton per meter square as the dead load. Then the life load, as we have been told formally, being residential, will have 1.5 kilonewton per meter square. So for our slab now, the ultimate design load for our slab, we know 1.4 GK plus 1.6 QK, and that would give us 1.4 multiplied by 6.3 plus 1.6 plus 1.5. So that would give us 11.22 kilonewton per meter square. All right, so that's our load from the slab. So we'll need this information as we proceed in our slab estimation, in our load estimation rather. All right, so the next one we want to determine will be our beam loadings. All right, so we do not forget that this is our roof beam at roof level, our second floor, then our first floor, then we have our ground floor. So how do we estimate the beam loadings? And do not forget that the section for our roof beams is quite different from that of our floor beams. You see, for our floor beams we have 450 by 225 mm. For the roof beam we have 200 by 225 mm. So it's quite different. So our estimation should reflect that rightly. All right, so we'll have the roof beam here first. Let's make calculations for roof beam. So we'll do beam own weight, knowing that the section is 300 by 225 multiplied by 24, which is the unit weight of concrete or density of concrete. You have 2.4 1.62 rather 1.62 kilonewton per meter. All right, and because the beam at that level is not supporting, is not expected to support wall at the roof level, it's only expected to support the roof load, of which will be transferred independently. So what we have at that level is just the roof beam, not supporting a wall. So that's exactly what we're going to have for the dead load at that level. So you may want to factor the results by 1.4, and that should give you 2.268 kilonewton per meter. Now for the floor beams, which are 450 by 225 mm. So the beam own weight now will be 0.45 multiplied by 0.225 multiplied by 24, and that should give us 2.443 kilonewton per meter. Now one of those assumptions we are going to make is that we assume that all our floor beams support walls. Now this is not a fixed assumption. If in your own case there are some beam span that doesn't support walls, you might do without it and estimate your beam loads without considering that. So but for this tutorial, We are assuming that all our beam span supports a wall, right? So the wall load now will have 2.87 multiplied by the height of the floor, 3 meters. Then that should give 8.61 kilonewton per meter. So the total dead load at this level should give 11.04 kilonewton per meter. All right, so we'll have the factored load 1.4 GK, and for this we'll have 15.46 kilonewton per meter. We'll have the what else now? We have calculated for the beam loadings, both for the roof and the floor beams. All right, so we'll have our results accordingly. But so there's something I want to just speak about here. For the wall load, if you want to be very precise with your wall load, instead of applying the whole 3 meter floor to floor height, you may want to remove the depth of your beam, of your floor beam, so that your wall is sitting just below your beam, something like this, just below your beam, something like this. So you are doing away with the whole of this beam 450, so that your wall is sitting right below that. I believe you really get that. In case you're not clear around any of my speakings, you might just do well to use your comment section, as I'll be there to answer to any of your comments, your questions, your query, and all of the things that you have to ask me. All right, so to go further from here, we'd like to begin to do some business around the column load transfer or load estimation. Yes, but before then, I want to make an explanation from here. Now, the column that we are considering today is the central column, which is column B2. This is B here, and this is 2 here. So we are discussing this central column. Right? The columns are supposed to support loads in this arrangement. Now, this is a central column, for example. When we have the half of this span, pardon me, when we have half of this span, then half of this span, then we have half of this span here also, and also half of this span here. When we have this arrangement, the column is supposed to support this area you are seeing, this area. That's the area the column supports, and that arrangement goes for other columns too. So the area within this region is such that this column, this central column, supports. The area within that region is such that the column supports. So how do I know that area? It's very simple. The span between the span AB is 6 meters in all. So having to divide that into 2, I have 3 meters, yeah. And having to the span between B and C is 5 meters. Dividing that into two, I have is it 5 meters that I have there? It's 4 meters rather. So I have 2 meters. I have 2 meters. My line just covered my dimensions here. 4 meters. Alright. So we have 2 meters that way. So in total, the length of this span here is 5 meters. Alright. From 1 to 2, the dimension is 5 meters. So from here we have 2.5. Then the other part we have 2.5. Then in total we have 5 meters. Now the area of that region, as we can see here, the area will be 5 meters multiplied by 5 meters, which is 25 meters square. So the area that slab that column is responsible to support is 25 meters square. All right, and that is what we are going to work with the slab loadings and also the roof loadings. All right, but when it comes to the beam, we are dealing with the length. Now these that we have already determined 5 meters, because if this is a beam, a little moment please. If this is a beam to be carried by that column itself on either side, it's still going to be divided the same way we did our first divisions, half into halves. All right, if we have beams in both directions this way, so it's going to be divided into halves as we have done it formally. So we'll have 5 meters on the vertical, 5 meters on the horizontal after we are done with it. So that means the beam to be supported, the length of beam to be supported is 5 meters on the vertical plus 5 meters on the horizontal. That's 10 meters to be supported by this column. And since we are taking the consideration of the fact that this layout arrangement is the same, consistent for all floors, so the length of beam is not going to change. But in the case where you have a varying arrangement, a varying arrangement around your layout, you may want to consider the change and apply accordingly. All right, so with these informations that we have just obtained, we can go ahead to do something on our column loadings. All right, so for the column loadings now, for the floor area, we have rightly discussed that and we all agree to have 25 meters square. The roof load, we'll have 25, which is the area of the roof that column is responsible to support, multiplied by the load of that roof, of which we had said in the beginning of the tutorial that is 2.0, the live and the dead load combined together. Then we'll multiply by a factor, the factor that could accommodate for the ultimate design load for that roof. And this 1.45 is trying to find an average factor between our dead load 1.4 factor and a life load 1.6 factor. So this is sufficient in helping us find out the ultimate design load for this roof. However, you may find a factor that actually works for you and yet still accurate. So but I've proven this to be correct for me, so I can go ahead with it. And also this roof load 2.0 is not a standard for every design, so you want to pick what is unique to your project. All right, so some might say 0.75 for live, 1.1 for dead, or 0.75 for dead rather, 1.1 for live. Some might just go for 1.5 for the combination of the dead and live. So however it is, your type of roof, the structure you're designing for, and all of those things might influence your decision on the factors. All right, so for this we'll have 72.5 kilonewton. Then we'll have our roof beam, and the roof beam is 2.268 multiplied by 10. That's going to give us 22.68 kilonewton. Also we'll have our column own weight, 0.225 multiplied by 0.225, which is the section, multiplied by 24 density of concrete, multiplied by the height of that column. Then we can factor it for dead load. That's 5.1 kilonewton. Adding this guy together, we'll have a total of 100.28 kilonewton. Now this is first the roof to the second floor. Of course we know that already. Roof to second floor. So that's sorted out. The next one we're going to do is the second floor to first floor. All right, so we'll have the slab, or before then we might want to transfer the loadings we just have from the floor above. Loading from above, that's 100.28 kilonewton. Then also we'll have the slab load now. And we know the area of slab that's transmitted already, multiply by the slab loadings, the one we did, 11.22. I told you to keep that value because we need that 11.22, and that's going to be 280.5 kilonewton. All right, so we'll have the beam load also. We already spoke about the length of beam that's to be supported by that column, and we agreed that is 10. And also we'll have the beam load, which is 15.46 for floors. All right, so 15.46 for floors, and that's going to give us 154.6 kilonewton. So we'll have the column own weight, which is going to be the same with what we already calculated above, 5.1 kilonewton. All right, adding for this floor, we'll have a total of 540.48 kilonewton. So calculating for the last floor, which is first floor down to ground. So we have the loading from above, to be 540.48 kilonewton. We have the slab load, to be 280.5. Reason being that the slab area is the same, the loadings for the floor is the same, so it's going to be the same thing for the slab and the beam also for both floors, and that's 154.6 kilonewton, and the column also the same 5.1 kilonewton. So the total we're going to have up to the ground floor, having done all this, we'll have 980.68 kilonewton. All right, so we might make a very reasonable conclusion at this point to say that the total load on column B2 or 2B, however we call it, is 980.68 kilonewton, say 1000 kilonewton. All right, and this would answer to how much. So at first we can make a conclusion that column B2 has a load of about 1000 kilonewton transferring, or that is being transferred to the foundation. All right, so with this, I believe you should be fine. We all now should be able to estimate our loadings on columns effectively. All right, so if you have any questions around this subject, you can do well to use the comment section, as I'll be there to attend to all that you want, all that you have to ask me. Until we meet next time in the next video, I am Joshua the Designer. Do not forget to like this video, subscribe to this channel, and share with your friend that should get better in structural engineering. Have a nice time. Bye.